Yeah.
You sure you ready?
Mm-hmm.
Okay, talk amongst yourselves. What just happened? All right, guys. Questions. What did you see happen? You saw fire. Give me more. Give me more than that. Tell me everything you saw. Go ahead. Okay, it spread from top to bottom. Okay, what else? Anything? Go ahead. Well, I dropped the match in. That's what happened. It wasn't when I took the mat. It wasn't when I took it off. It was when I put the match in. Okay, what else we got? Go ahead. Very loud noise. Okay, what else we got? There's something that nobody's. You saw smoke? Seriously? What's that? Okay, I was spinning the bottle beforehand. You remember? Do you know why? So you don't know why I was spinning it before? Okay, we can talk about that. What else we guys got? Anything else? Go ahead. You guys don't even have to raise your hand. We're just throwing out things. So that would be like that top to bottom flame thing. Okay. So it was a sealed container before I. Well, it kind of has to be, doesn't it? Because I was protecting it. What he was talking about. Why did I spin the bottle? I put it in as a liquid, and then if you guys remember at the beginning of the semester, I told you guys one of those things I want you guys to remember 5 to 10 years down the line. If you don't remember much else about this course, I want you to remember this one thing, and that is that all reactions happen at the surface area. So when I'm spinning that bottle, what I was doing is I was spreading that liquid around the surface area of that bottle. I'm spreading it around, and by doing that, I'm making the surface area of the liquid much, much bigger, which gives it much more surface area to evaporate. So it becomes a gas faster. That's the whole purpose of that. Um, and it mixes with the oxygen that was already in that bottle faster. And that was kind of important. I wanted it to be completely mixed with the oxygen in that bottle. And that's going to be something we talk about in a little bit. But there's some other things that happened, and I wanted to see if you guys can catch on to them. Anybody else hear or see anything else? Yes?
It kind of sounded like it propelled gas out of the
It propelled gas out of the bottle. Do you have any evidence of that? There was something that happened that proved that. Did you hear what that was? Go ahead, Nico.
Like a pillar of fire came out the top right as you put the match in.
There's the pillar of the fire. Anybody else got any ideas? There was something that happened that most people miss because they're so focused on the bottle that they miss something. People last year did not miss it because something happened because of it that made it impossible to miss, which is why I now stand up when I do this experiment. Last year, when I was doing this experiment, I was sitting down over there, and the force from the experiment went up, the ceiling tile went up in the air, and then it came down onto the bottle. So it shot up enough to where it came down. It actually fell out of the ceiling tile. That's what that corner is up there that everybody in 8th hour signed it. It broke off, and we kept the corner up here on the light box. They signed that corner. We kept the piece. So, and then they took the rest of the tile and they replaced the tile. But we kept that as a souvenir. But now I stand up because if you guys didn't hear it, when you hear it, you saw that, and then you probably heard this little. That was actually the ceiling tile going up and reseating itself in the thing there. And that is the evidence of what Anderson was saying, that gas was being expelled out. It created force that forced that ceiling tile to go up and then seep back down into the tray up there. Okay? So we know that it made fire. Understand that fire is not particulate matter. This is actually some area of debate. There's some people who claim to be really, really big scientists, and they actually want to have this big debate. And there's some scientists who want to claim that fire is plasma. By definition, plasma is a gaseous cloud of charged particles. Fire is actually two different things. Fire is a combination of two forms of radiant energy. It is colored photons of light and radiant heat. When those two things are combined together, you have fire. So since there's no particulate matter to it, I am in the camp that says that it cannot be plasma. Does plasma look like fire? Absolutely. If you look on my YouTube channel and you see where I made the plasma in the microwave, it absolutely looks like fire. But regular fire is not plasma. Does that make sense, everybody? So we know what happened. Now we want to know why. Why did it happen? Talk amongst yourself. Why did it happen?
Mr. Cole, was the solution in the bottle ethanol?
No, it's methanol. I would not waste ethanol like that. All right, anybody have any ideas? Toss them out at me. Why do you guys think? Why did these things happen? Tell me some of your ideas. What are you thinking? Why did we see fire? Why is there force? Why? You guys were talking, so there had to be something. You had to have some ideas. Go ahead.
Maybe it's like how the stuff in the bottle, it reacted with the flame of the match, and then while its like reaction was happening, it like turned a little bit into gas.
Okay.
Then expanded and was more than there was room in the bottle, so it went out the top.
Okay. Can I just tell you what you just said is actually very intuitive. It's actually something that you don't even know how awesome that was.
Thank you.
That was I mean, I'm getting good. Look at that. Goosebumps right there. That is freaking awesome. That is exactly what we want you guys to be thinking. What you just had was this substance called methanol. Methanol is CH3OH. That's a carbon that has three hydrogens and a hydroxide group connected to it. As we were talking with Brian, I said I put it in that bottle and I was spinning it around so I could increase its surface area so it would evaporate, so it would mix with the oxygen that was in that bottle. When it mixed with that oxygen in that bottle, I could then add a match to it, which is heat. When I added that heat to it, it caused an ignition. That ignition caused all of those carbon and hydrogen and oxygen to separate. Now, this substance right here, if you haven't already done so, I would make sure you guys have a notebook out and write notes. This substance right here, which is a substance that is composed of a carbon, a hydrogen, and possibly an oxygen, is known as a hydrocarbon. Anytime that you have a hydrocarbon plus an oxygen, we will call that a combustion reaction. So anytime I see a hydrocarbon plus oxygen, I know that I'm going to be making some fire up in here. Okay? When you get to biology, you're probably going to see a hydrocarbon plus oxygen and you're going to be calling it something like respiration or some other type of cellular fermentation or something where you're going to be producing energy. But every time something like this happens, you're making energy happen. Something is going to be involving energy. Okay? Energy is always involved in this type of reaction. In this case here, we're going to be making fire. But the good news is that it always makes the same thing. Yes, ma'am.
Sophia here.
Sophia, can you please come up here? Every time I see a hydrocarbon plus oxygen, I'm always going to make carbon dioxide and water. Nice and easy, right? It's always the same. Is everybody cool with this? Now, here's the cool thing. This is my chemical reaction. I have written all of the correct formulas. This is methanol. This is oxygen. These are my reactants. Reactants are on the left side of the equation. My arrow indicates when the reaction occurs. On the right side of my equation, I write the products. Carbon dioxide and H2O are the correct formulas for my products. This is known as a skeletal equation. Okay? A skeletal equation means I've written the correct formulas, but it is not balanced. Does everybody understand that? I don't have necessarily the same number of atoms of each element on both sides of the reaction. But I do have the correct formulas. At this point, I will never, ever change a subscript in order to balance a chemical equation. Does everybody get that? So what did I just say, Theodore? Nope, that's not what I said. What did I just say? Let's go with Danny. Nope, that's not what I said. Nico, what did I say?
They will never ever end.
Nope, that's not what I said. Brian, do you want me to repeat it? Nope, that's not what I said. What I said was, once I've written a skeletal equation, I will never, 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 ever change the subscript in order to balance a chemical equation. Mariana, what did I just say?
I forgot.
Oh, no, that's not good. You want to try it, Lexi? No? Cam, go for it, bud.
Once you get this skeletal equation, you'll never, never,
Nope, that's that. Not right. I'll repeat it again. Once you've written the skeletal equation, you never, 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 ever change a subscript in order to balance a chemical equation. Want to try it, Faith?
Once you've written a skeletal equation, you never, ever, ever,
Nope.
never.
You want to try it, Izzy?
No.
Come on, you can
Izzy,
do it.
do it. No, I
You can do it, Izzy.
It's like
Brittany, you want to try it?
once you get the skeletal equation,
Nope. You're getting there. You're close. Crazy, you want to try it? No, you don't even want to try it? Alex, you want to try it?
Once you get a skeletal equation, you'll never, 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 ever, ever.
Nope. Nico, go for it.
Once you get the skeletal equation, you'll never, 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 ever.
Nope. Cadence, you want to try it? Not really? I'll repeat it again. Once you have written a skeletal equation, you never, 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 ever change the skeletal or change the subscript in order to balance the chemical equation.
I got it.
I give up.
Katie, you want to try it?
I got it.
All right, Cam, let's see it.
Once you get the skeletal equation, you'll never, ever.
Nope.
No, ever. Just never, never.
Okay,
No,
brother.
I meant never, never, never. I haven't counted out.
It's like 7 years.
No, it's,
Never, never.
it's 5 never.
All right, Miller. Good job, buddy.
Bruh.
All right, hey, why am I asking you guys to do it this way?
To really remember it.
Well, why though? It's very important, but one is mastery. Gotta go through this one. I'm trying to get it repeated more and more times. The more times you hear it, the better chance you're gonna remember it. Always. Number two, brain research. The more parts of your brain you can write something in, the more you retain it, the easier you can recall it. So we're saying it out loud, we're repeating it over and over, we're having you say it, I'm saying it, the friends are saying it, so there's a social aspect to it. Okay? There's auditory, there's verbal, there's listening, all of that's involved. And then there's what's called the double triple. The never, 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 ever is the double triple. That opens the musical aspect of your brain and writes it into another part of your brain. So the more parts of your brain I can write this in, the more you retain it, the easier you can recall it. This is important. If you change a subscript at this point, you're not balancing it, you're changing what the substances are. You're changing what the equation is. Okay? You're not writing a correct equation at that point. You're writing an equation for something else altogether. You cannot change a subscript at this point. Once you have written the correct formulas, you cannot, under any circumstance, change a subscript. You must use coefficients to balance this equation. Period. No way around it. Have we got that? All right. Homeworks tonight, pages 7 and 8. Homework tonight is pages 7 and 8. Give you guys the rest of this time to work on it. Okay, back to this. We've now got our skeletal equation. How do we balance this now? There's a couple ways that you could go through this. A lot of people will do what's called an atom inventory. In this case here, you could say carbon, hydrogen, oxygen. Okay? I look over here and I say I have one carbon over here. I have one carbon over here. That's nice and easy. I don't have to do anything else with that. I have 4 hydrogens here. How do I make 4 hydrogens over here? Right now I only have 2. How do I make 4 over here? How do you make 2 into 4?
Add 2.
You can't add, you have to multiply.
Multiply by 2.
So I'm going to put a multiplier of 2 here. So that makes this one into 4. Now, when I do that, now I have to add up all my oxygens. I have 2 times 1, that's 2. 2 times 1, that's 2. So it's a total of 4 oxygens here. Over here I have 1 times 1, that's 1. 2 times 1, that's 2. So it's a total of 3. So 4 minus 1 makes 2. So 4 minus this makes this 4 minus 1 makes 3. So this makes 3 over 2 that's left. That's not going to work for me, is it? So how do I fix this? I'm going to multiply this whole thing times 2. And what I'm going to end up with is 2CH3OH plus 3 O2s will produce 2 CO2s plus 4 H2Os. And now I am balanced. Does that make sense to everybody? We all riding the same roller coaster today? So let's do our atom inventory to make sure we're correct. Now I have 2 carbons. 2 carbons over here. I have 2, there's 3, 4, 2 times that makes 8. Then I have 8 hydrogens over here. I have 2, and then I have 6, so that makes 8 here. And then 4, 4, that makes 8 there. So 288, 288, I'm balanced. Everybody see how that works? Is everybody happy with this? Okay, remember, pages 7 and 8 are your homework for tonight. Check your homework from last night. The keys are up on Canvas.